All right, thank you. Okay, it sounds like this is working. As he said, my name's Christina Padron. I'm from a company called Design Interactive, which is out of Orlando, Florida. And today I'm going to be talking to you about a human factors approach to AR navigation design. So the premise for this whole talk is a project that we did a few years ago where we were asked by a manufacturing client to come up with a concept to show how we would design an AR application for their maintenance workers, right, to help with standard operating procedures and things like that. So what this picture is here is actually when we went to do the user research. This is where one of the more experienced maintenance workers was kind of showing us around, walking us through one of the standard operating procedures, and you can see here that the conditions, it had just rained, right? They're outside. There's puddles everywhere, so tripping hazards. And actually, according to OSHA, slips, trips, and falls account for 15% of accidental deaths, so that's obviously a pretty big safety hazard. And then, as you can see by the tracks, there's vehicles driving around, things like that, equipment all over. So kind of a non-ideal situation to be carrying around papers, following standard operating procedures, things like that. So our big concern was how are we going to be able to support them using AR and ensuring that it's still a safe environment and while being able to increase the efficiency and the effectiveness of the maintenance workers. In this case, they specifically wanted it on a tablet because it would be, because it could be a ruggedized tablet. But it got us thinking as we were doing the design and the development of that application, what could we do if we didn't really have that constraint on it? How would we design something specifically in a heads-up, hands-free type of technology? And so we developed a concept video for that, and I'm going to be showing that in a few minutes. But overall, the most important thing is that the system has to be designed to support the human in performing the specific tasks in the particular context of use. So what I'm going to be kind of trying to touch on today is how there's a lot of features that are available, and over the past few years, especially in XR technologies, a lot of new features are becoming available all of the time. And so I think it feels like there's kind of a race to who can get the newest, greatest features in their products as soon as possible. And I think the important question here is not necessarily what can you do in your design and in your products, but what should you be doing for, again, the human with the tasks that they need to do in the context that they're doing it in. So in this case, there were a few things we were looking at. The purpose of the solution was operational support. It would be designed differently if it was a training application or for entertainment or some other purpose. The users were maintenance workers with a range of experience. It's important to understand the characteristics of the users. Experience is a big one because in design, a novice usually wants, or pretty much always wants, a lot more assistance, whereas an expert really wants the ability to be able to turn off some of that additional assistance because they don't need it, and therefore it can become distracting to them from their task. And then we looked at the tasks. So in this case, it was following an SOP from a work order. The important thing about the tasks are what are the cues that are necessary to know if a task was completed successfully, and also how to know that it was not completed successfully or that something went wrong. So when I say cues, I mean visual, auditory, haptic, potentially olfactory cues to know really how they know if it was done successfully. And this is something that experts generally can tell you, and that information may or may not be in SOPs, right? It might be something that they've just learned from years of experience, and they can tell you just, kind of offhandedly as they're going through stuff, and it's stuff that, they might not even realize they're using as cues. And then finally, the context of use. So in this case, it was mostly daytime. They're outside, so weather could be a factor. They might receive other calls, so how can the AR help them to remember where they were in the SOP, right, if they have to go address something else and come back? There's potential safety hazards, as I talked about, and then so time pressure and stress from that time pressure can be a factor as well, because when things are down, that costs money. So there's this stress, and stress has certain impacts on people as well. So important thing to keep in mind. So how can AR support is the question. So there's certain capabilities, obviously, of AR technologies that are important to consider when designing the application, right? So choosing the hardware is an important, first consideration. So there's mobile versus head-worn AR. Obviously, the head-worn is hands-free, which is the big, really the big draw, especially for something like maintenance. That generally you're using your hands a lot for that, so being able to have your hands free is important. The size, especially from the perspective, not just the size, but really the form factor in general. They have to wear, like they had to wear hard hats in this case, so that's absolutely a requirement, right? The safety equipment that they have to use is absolutely a requirement. So how can you integrate the AR application with something that still will allow them to wear the required safety equipment? And then spatially aware versus not. So the real-time mapping of location is obviously a really important thing, especially for navigation around a plant, and understanding where the equipment, and then you can also use the AR to map out safe versus unsafe areas. So if there's places in the plant that you can't go or that are not safe, the navigation can take you around that. And finally, GPS, so your location in relation to objects mapped so that you have an idea for situational awareness perspective of where you are in relation to the other equipment. So in developing this concept video, we looked at best practices from different industries, including gaming, military, and consumer industries. And these are some of the kind of design features that we explored when we were designing this. So visual landmarks, having a world in miniature representation, as well as a map of objects, a distance counter to let you know how far you are from waypoints or terminal points, bounding boxes to direct attention to certain equipment or objects, and then multiple call-outs of surrounding tools and locations, again, to show, to be able to direct attention to certain things and show kind of where options are. So the next slide is going to be the video. So the elements in this, the design elements that are called out in this video are specifically meant to help to make sure that safety is ensured and potentially even help with the safety beyond what they currently are able to do, just walking around with the paper in their hand. But then also help to increase the effectiveness and the efficiency of tasks that they're performing, and also generally increase situation awareness within the plant. Okay, so now I'm going to go in a little bit more detail, just kind of talk about some of the things that were called out in the video. So in terms of safety support, you saw some things such as safety warnings, so watch your step. I should say that this assumes, of course, that the AR application is networked in with the system, right, for the from the company themselves, so all of this information would be pulled from their database and their SOPs and everything. So watch your step, safety reminders such as wear gloves, virtual path overlay. So I think this is one of the things where, in terms of safety, even from the whole perspective of just because you can doesn't mean you should, I think that in this case, having the path overlay, one thing I've realized from this video is that it's pretty opaque. I think that if we were to do this again, we would make that path a little bit less opaque, more transparent. But then an important thing here is completely removing it when they go over steps, because again, we don't want to obstruct their view of something and make it actually less safe than it would have been originally. So I think that's kind of one, that's my favorite design feature that's highlighted in this video. And then some other ones that we thought about that weren't included in the video, alert to oncoming traffic. So because, as I said before, there are vehicles driving around, being aware of where they are in relation to you and the other equipment, as well as kind of when they're coming closer, when they're coming in your direction, things like that. And then smart no-go, no-go areas, again, are things that can be mapped out on the miniature map, as well as things that you're alerted to as you come close to those areas. In terms of increasing the effectiveness of tasks, having a digital twin of the equipment is something, actually one thing that I didn't mention from the original story is that actually as the maintenance worker was walking through the SOPs, there was one lever at a step that had a picture in the SOP. Turned out that the picture of the lever was the incorrect picture, so it actually was, if he had actually opened that lever, it would have released a toxic gas that would have, not only is that unsafe, they would have had to clear out the whole facility, costing thousands, probably hundreds of thousands of dollars to the company. Anyway, so the point is being able to have something like a digital twin of the equipment, obviously, the ideal of that would be using object recognition for the AR to just recognize, yes, this is the correct lever for this, and then you can confirm that before doing anything with it. Use of color to indicate successful task completion, also giving notifications to confirm, and then terminal points. So there's the waypoints that you see along the way, and then the terminal point indicates you've made it to your destination. Oops, sorry. Okay, in terms of increasing efficiency of tasks, there's the virtual redundancy guidance, so mirroring the screen. For anybody who's done any work in manufacturing, you may have noticed that some of the user interface screens can have some very complicated diagrams on them, or networks of things, or just a lot of information in one screen. So I think the major benefit of this is that it directs your attention to the aspect of this, the area of the screen. That's really important. Another way to be able to do this is just draw like a bounding box around on the actual screen to show exactly where their attention should be focused. And then color and dynamic animation. So of course we have the path that's on the ground, but to get you to efficiently move in the right direction, the arrow that you saw that came up in their line of sight to direct them, you need to move this way to go to the next step, also helps with efficiency. And then waypoints help with safe and efficient pathfinding, as well as, again, the terminal points to show you that you've made it to the next destination. In terms of situational awareness support, there's a miniature world map with icons, so being able to have positional awareness within the facility, so where are you in relation to all of the equipment that you'll be interacting with, or just important equipment in general. Having virtual landmarks, which can improve the familiarity of your surroundings. So having, I think, the virtual landmarks helps with also communicating your position to other people in terms of something, having a reference point. These may be more useful in a place that doesn't have as much equipment, so that, in kind of a more wide open space, to give something to have a reference to be able to say where you are and understand where you are. And then finally, smart distance counters. This may or may not be helpful from a kind of walking perspective as opposed to, driving. Obviously, that's a helpful thing for driving. But it might be, it also could be something that's useful just to give you the awareness of how far you are from the next waypoint. These are a great example. That's a great example of something that I would imagine an expert probably wouldn't be as interested in having as maybe a novice who's not familiar with the facility. So overall, it's really important, I think, that you make sure that the system is designed to support the human in doing the tasks that they're doing in the particular context. And again, really the critical question is not what can you do with the technology, but really what should you do for this particular situation to support the user. And that's it.
What tools, software did you use to develop the augmented training?
On the tablet itself? Yeah. Good question. I can't actually remember the answer to that, but I could get back to you on that.
Yeah. So it was great. It was really useful. Do you find it difficult to balance? There was a lot of custom, like this is the route, this is the sequence. Do you find it difficult to balance that and the time it takes to develop that custom AR experience? Because that's like maybe one specific solution, one specific task, versus like the many different tasks that people have to do. I mean, trying to leverage that very custom, the amount of time it takes to make that versus a tool that can cover more of what that operator has to do. I mean, it sounds like it's difficult to balance that.
Yes, it is, and actually, that's something that we're always looking for ways to be able to actually develop things that would empower the user to be able to kind of author that content themselves. This kind of thing, of course, is this is more of a concept for now, so it would have to be more of a custom solution, but that is always, in any way that we can make our designs modular and something that, can reuse content, we do that as much as possible. So, but that's a great point. I mean, it is tough to balance that. Yeah.
Hi, in situations where the workers have to follow a whole bunch of steps, are there ways that AR can make them feel more empowered and not just robots that are following the steps?
That's a great question. I think that, let's see, is there a way that AR can help them feel more empowered? So I think that as much as AR can really support them in actually conducting the tasks themselves, so any of the information that can be provided by AR can maybe help in I guess in helping them, do it more efficiently. That's a great question. I would have to think about that a little more to come up with a better answer. Thank you. Sure, I'd love to hear.
I think the response to that could be that enable the worker to give feedback on the product design. They're the ones that are out there probably fixing fans, fixing clasps, fixing this, and they can tell you that this plastic isn't working, that this hinge breaks all the time, I constantly have to fix it. So that, I think, lets them not be a robot and lets them be an active participant in the product design.
That's a great point. Thank you very much. And actually, that is an important part of our design and development process that we always do is user testing and getting feedback from users. So that's an excellent point. Thank you.
Other questions?
So I noticed that the footpath that you had had 2 levels of it. So once you went up the ladder, like what was the sort of marker by which you identified a second floor, or was that all GPS based? Like how do you tell multi-level scenarios?
So actually, we wouldn't go up to a second floor. So, or do you mean? So I guess if you were to actually go up and follow a path that's on the same level. Is that what you're saying? Because we specifically took the path off for the stairs so that they could go over it. But you're saying just basically how would the AR technology know that they're elevated from the ground level? That's a great question. I do not have the answer to that question. That's a great question that we would have to, and possibly our developers would have a better answer for you, but I'm not sure of the answer to that.
One last question.
So I noticed that when you had the input, the color would change when you completed the task on the screen. How are you identifying that in the software solution?
Yeah, so the assumption here in this video is that the AR application is networked in with all of the equipment, all the status of everything, what's going on, and it's being updated in real time. So that's how it would know, because the system status basically would change to identify that it's been successfully completed.
Was the development completed and deployed, or was just a concept piece?
No, in this case, yeah, we actually did a concept. We're still kind of working with that customer to do the development, but this was a concept video for now. Mm-hmm.
First of all, thank you. That was very helpful. Ours is an AR journey between an African American and Latino community with several sites, and people getting them to cross the boundary between the two communities. And what happens when they enter the other community, and because it's exciting, they don't cross the street safely. And that's what we found in our test. When they're from either side, they're not noticing the streets, and we're finding that it is more dangerous than we anticipated. Okay. And I'm wondering what recommendations you have. They're following digital ants, there's a lot of music, and our journey isn't safe.
So I would have a few follow-up questions for that, so maybe I can talk to you after. I would love to talk to you more about some of the details of that.